I think all of us are familiar with the Arduino platform, but if you ever need something with a bit more grunt or something more powerful than the Arduino, I think you should take a look at the board in front of you. This is the STM32 F4 Discovery evaluation kit. It is designed by ST Microelectronics to promote its 32-bit ARM microcontroller range. Its value for money actually is really amazing. For the same price as an original Arduino Uno or Leonardo, you get an extremely powerful chip on a board with some great peripherals. So for the cost of the board is actually around 1,450 rupees. So while that might seem a lot at first, the actual value for money, actually what you get, is definitely worth a lot more than that. So let's go into some of the details of the board. This particular chip is the F407VG MCU. It's a 32-bit ARM Cortex M4 based microcontroller. So because it's Cortex M4 based, you have all the advantages like you have floating point coprocessor and things like that, so you can take advantage of those. This particular chip is clocked at 168 megahertz. It also has 192 KB of RAM, and you also have 4 KB of backup RAM if you ever need one. It also has 1 MB, 1000 KB of code memory, so you almost never have to worry about running out of code memory like an Arduino. So let's take a look at some of the peripherals you get on the chip, some of the features of the board itself. So over here you see you have a 3-axis accelerometer, and that is connected to one of the I2C ports of the chip. You also have an omnidirectional MEMS microphone, and you have a 32-bit, you have a 24-bit audio DAC that's connected to a 3.5 millimeter audio jack, like the ones you can connect your headphones to. And the audio DAC also has a Class D speaker driver on board. You also get one user push button. This is for the reset button, and you also have 4 LEDs around. And I think the best part of the board is on top over here. This is an integrated debugger. This part here is an integrated debugger, hardware debugger for this chip. It's the ST-Link V2 debugger. It's the same design. It uses the same chip, everything, as on the actual hardware debugger ST micro cells, the ST-Link V2. So you have mini B connector to program this chip. You also have a micro USB connector for USB on the go, USB client functionality. So if you have a USB stick you want to interface with, you can connect it over here. And all the 100 pins on this chip are broken out onto these headers on the side. And yeah, those are the features of the board. So when you actually get the board, there's some demo firmware, there's some demo programs loaded on the chip itself. So when you connect power to it, we'll see what happens. I'd like to go over some programming options for this board. The suggested IDEs and toolchains from STMicro's website are all crippled IDEs. Crippled meaning they restrict your code space to 32 kilobytes, or they have a 30-day free trial, etc., etc. So I would rather not use any of those. So, but not to worry, there are definitely other better ways with no restrictions to program this board. One of them is the ChibiOS. ChibiOS is an open source real-time operating system for that has native support for the Discovery F4 board. And I'll link the description of that OS and to their website in the description below. And another IDE is the Kucox IDE. And again, Kucox IDE is an open source development environment that also has support for the F4 board. Another thing is you can use this ST-Link V2 programmer as a standalone programmer for programming other ST micro chips. So it's definitely this board is definitely a good buy.
And also another thing is, if you're familiar with Eclipse, you can build ChibOS applications using Eclipse. So if you're familiar with Eclipse, I think that's the way I would go about it. ChibOS is also an extremely active community. They have amazing documentation and lots of examples. They also have drivers for things like PWM, I2C, SPI, etc., etc. So you can get help on their forums, look for examples, code examples, everything. So I think this board has a huge community behind it, and you won't lack for examples. I think that's for sure.
As you can see, I've just connected the board to my computer via a USB cable, and you can see that the 4 user LEDs are glowing in sequence. And if you press the user push button, you can see that the LEDs go off and the accelerometer demo begins. So if I tilt the board in this way, you can see that the corresponding LED starts to glow, and they're glowing they're blinking slowly at first, and they become more faster and faster the more I tilt the board. And you can see that they slow down when I bring it back to level position, and that is the accelerometer demonstration. And if you press the user button again, they go back to blinking in sequence. And so that ends my video for task number 3. And I think that this board is really amazing, and people should consider it in the next project. Thank you.